a system call with our ARM64 assembly. And then I found a sleep.s file, sleep assembly file, which should work. It compiles, it builds, but we need to implement it right. And then we also want to add it into our loop. And so the idea is what we'll have a loop that prints out something every so often, like maybe once every second. Architecture, we're doing ARM64, Matthias, good question. ARM64 is the assembly today. That's the architecture. Let me show you the build file really quick. WS, here we go. Look, the build file. Here's the build sh. There you go. Architecture, ARM64. There you guys go. Here we go. Okay, so let's do the system call on sleep. Here's the goal for today. So we've got this sleep file over here, sleep.s, and it's so text represents the code. This is the start of the code, right? So we know that. We learned that start of code section. Yep, start of code section. You got it. Align to tells the bits, right? So we're going to do align to 4-byte boundary. And then this is a function call, I think. This is the function call. So we've got something called underscore sleep and s. So sleep nanoseconds. This is like a function call. So if it's defining a function. So in this case, it's kind of like this in C, but also maybe it's like function. And so JS would look like this. It would be like a function underscore sleep. Here you go. So it'd be kind of like this. And then in Python, it would be like def, right? Def sleep nanoseconds. Like, check it out, you guys. Look, x0 is the argument for the function. This is x0. This is like the nanosecond. X0 is the nanosecond because, look over here, if we open up main, then I call it by putting data into x0. Look, you guys, look, right there. Do you see? On line 15, x0 and x0 over here, I've just passed data to a function, right, using BL branch. I don't know what the L stands for. I'm calling a function of some sort. But here, isn't that cool? We just figured it out. We figured it out. We're saying that we want it to be 500 millisecond sleep. That's the idea. And then we go over here to kqueue, which I know is a kernel, or in this case on Mac, it's kind of like epoll or poll, is a way to register events and do event-based exchanges with the operating system and your application. There. So I know what kqueue is. Kqueue is like a poll on the system. So let's see. Let's go over here. Open this. It's a sys. We're going to do a syscall to, I guess, register an event for kqueue, and the event is going to be accessing, I believe, the system clock is what we're going to do in some way. We need an event to trigger after a set amount of time, then that will interrupt our application to then move forward, and that's kind of how the sleep works. I believe that's how it works. So we're moving data from here, there, and this is 500 milliseconds. kqueue, all right. So then we're doing move. I understand move zk. These are different byte levels, so that way you can stack up larger numbers, basically. And so 1 million over a nanosecond. So move. So now this is, I remember this. So this is going to say we need to call kqueue, which happens to be this number. I don't know. System kqueue is 3612. I'm actually kind of curious. Let's double check that, you guys. Let's go 362. 362. There we go. Is this syscalls? All right. One check it. So, okay, so it is. That actually is. Check this out, you guys, right here. Look at it is. Syscalls is this number right here. Whoa, wait, you guys, hold on. Time out. What are we looking at? What is all this? Are all these things the different system calls we can do? Whoa, I know it says deprecated, but syscall, sysexit, sysfork, sysread, syswrite, sysopen and close? No, wait, hold on. Is number 6 close? Wait. Are we using number 6 at the bottom? So wait, there's a syswait? What is that? What is syswait for? I don't know. Look at all these different things we can do. Wow. This is amazing. What about poll? I'm curious. There is a poll. There's a sys poll, but we're using kqueue. kqueue is what we're doing. So we're using kqueue, syscalls, which is 362. 362. This is great. There's K event as well. I wonder, are we using 363 anywhere? 363? We are. So, okay, interesting. Okay, so we're using basically kqueue here to get our sleep to work. So I know it builds, but does it run? I think I was having some issues earlier. ./main. Is it going to run? So it runs, but it does. What are you trying to do in assembly today? Okay, so today's goal in assembly is do a sleep and then convert int to string. And so we just walked through our sleep. And so our sleep is over here. So we have our sleep. We put it into a different file because there's just too much going on. So we have this sleep file right here. And it defines a function with one parameter, which is here. Here's the parameter. And that parameter is going to be the length to sleep, how long to sleep for. And I have it building and it works, but it doesn't, I think it's sleeping for too long and I need to figure out how to shorten the sleep. I'm pretty sure that's what's broken with it. Here we go. All right, so we're almost done here. So here's where we sleep. And I'm pretty sure my numbers are too big. So I need to reduce these numbers. And this right here, I understand this part is we can't just put into the register a really big number based on my assembler. It doesn't support it. So we have to move Z, K, and K into the X0 register, which we know is the first argument. So X0 is the first argument to the syscall, which is going to be the number of nanoseconds. Isn't that cool? I think that's really cool. So basically, that's like calling the sleep function with the X0 as the first argument or the first member or, yeah, I guess parameter. I think that's really cool. Use GPT. There you go. Yep, that's the way to do it. You can see it's still sleeping. It's still sleeping. It's too big. It's too big, so I need to reduce it. So I think I can reduce it by doing that. Let's do ./build, and then we'll do, if it builds success, then we'll do main. Okay, so it succeeds, but it's still taking too long. See if we can shrink it further. I think I can just do that. Is that enough? Let's try that. What we should see here is it prints hello world every so often is what we should see. It should be printing hello world. It's still, there's nothing happening. It's a static screen right now. Let's see. I think we need to keep going 0. So let's do that again. Let's do 0, 0. Is that enough? What if we did this? What if we did 0 here? Let's just put everything to 1. Let's just go as far as we can. Let's just go, we'll go 1, 1, 1. Let's see what happens if we do that. Is that good? Okay. It's still not working. It's still, I still don't see anything. So, oh, look, it printed hello world. It printed, but it's taking a really long time. Oh, you guys, look, we did it. We did it. We're doing a syscall right now, and we're doing a syscall. We're registering with kqueue, and we're adding an event listener to trigger an event after a set period of time. The kernel will interrupt our program saying, hey, the event triggered, and then it moves on forward. And that's how that works. Maybe if we put that to 0, maybe that's going to be better. So let's see if we can make it go faster. Nope, still pretty slow. That was for branch and link, so it saves the current address. Oh, it does. Okay, and like the label of the current line before calling it. Okay, gotcha. So it does do some placeholder in. Blade Z, I meant it will run forever, but you can use a counter and the branch conditionally. Oh, really? So you can, got it. Okay, so you can exit, or you can sort of, it knows where to, got it. Okay. So if we do a loop, right? So it knows the loop here when we branch, and then we can say escape, like we can exit the loop. We can do that somehow. We can do it conditionally, right? We can exit the loop here conditionally somehow. That's how it works. So what if we did 1 here and we put this to 0? What if we did that? Is it going to go faster now? Oh, okay, we did it. Okay, perfect. It's a little too fast now. Just a smidgen too fast. All right, let's see if we can make that go. So if we do 1 here, what if we do that? Is it going to go a little bit slower? Nope, still too fast. Okay. What if we did? What if we brought it up here? What if we did something like this? 1 here. All right. So maybe we're figuring it out. We're figuring it out. Is it okay? Okay, perfect. This is what I wanted. This is it right here, you guys. We figured it out. What is your end goal to learn this? So with assembly, the end goal was just to mess around. We're just learning. We wanted to do a system call. We don't have time to convert an